Thank you, Andrew, for inviting me. I think it's the third time I'm speaking at the Chinese W3C event. So I have been working in this field for 25 years. That's the year 2001 when I became a PhD student in Iowa State. And then I joined the Tim Berners-Lee's group and the Jim Handler's group. So it's kind of, today I'm 50 years old. It's half my time spending on this thing. I'm still working on it. It carries a lot of dreams, and we have up and downs. But finally, I think we find a way. So it's many different things. It's the 20th year's birthday of W3C China. It's the 25 years anniversary of the Semantic Web. And we have a long way to go. My postdoc advisor, Jim Handler, said semantics goes a long way, and this is indeed a long way. We have done so far before, but let's look back. After 25 years, what did we get? What did we achieved? What is different from we originally imagined? I borrowed this slide from one of my old talk 10 years ago at Wuhan. At that time, I split the history of web into 4 phases. The first phase is before 2001 is the dark web. And the second is the social web. And that's terms we are very familiar with. But then I call the next decade is data web. It's all about data. So semantic web actually is about data. So when we give up the original name of semantic web, we basically gave up the semantic part, and we renamed it knowledge graph. But where is the knowledge in knowledge graph? Knowledge graph has no knowledge. So the only thing left is data. It's just data, no knowledge. And that's why that decade is called data web. But I thought we can add it back. But I just don't know how. The next decade, I called it the intelligent web. At that time, we don't know how to achieve that. But now we know. The missing part is back. And the thing when I talked 10 years ago at Wuhan, that we don't know clearly is how do we get semantics back? Not just data, but also with semantics. And at the same year, transformer is released, but at that time, I don't know. Now, with all the tech stack of large language models, agents, like Jody just said, we basically get everything, all the power back. Then we have finally found a way to achieve the semantic web, but not using the way we originally thought, like description logic, OWL, RDF with a different approach. So large language model is the missing pieces of semantic web. I've been working on RDF and OWL for a long time. I was a member of the OWL2 working group. I authored 3 documents in RDF and all. So I have a lot of personal emotion associated with the standards. But I have to admit, they have flaws. So RDF is never universal. OWL is never really successful. Manually created metadata is too costly, and the so-called machine-made turned metadata is just transfer from one structured data to another structured IDF. Actually, I don't think they had added value in it. So the real part is how to turn unstructured data, low-value data into valued data. That's the thing we missed. And also, RDF is very strictly stick to naming with URIs, which does not turn out to work very well. So we have to revise. Now we find the one possible approach that let machine read human language. Of course, in the past 2 decades, a lot of people try to do that, but not until recent, like 3 months or 6 months at most, we finally find it works. Yeah, it works. So let's compare the original 2001, the Semantic Web paper vision with what we have now. So basically, I think the only thing kept unchanged is Tim Berners-Lee's vision that we have machine-readable data, which is universal, that machine can reason with that, and that thing is unchanged, but almost everything else is changed. So like, how do we present data or knowledge in ontology? What ontology is the making of? What's the gravity of knowledge? Like triple, is triple the best way? Or how do we find triple? How do we edit triples? How do we naming things? And so on. So it's a lot of things we have coming along the way, like linked data, semantic wikis, or like Tim said, social web, social machines. All this concept, we have revised it. And I think to some extent, actually, we achieved most of them, but not with the original vision, not with RDF and ORs. Okay. So the vision is right, just approach is not quite right. Of course, in academic and in research is common. And what we have now, let's compare that to another very influential paper that's Natasha Noy and Deborah McGinnis in 2001, that Ontology 101. That's the approach I was taught in school. And compare that to what we actually practice that works in engineering. It's very different, but I won't go through the details, but the most important difference is in the original Ontology 101, the approach is top-down, that we have structures, we have concept structure, property, we design that, and design with more details. This is a top-down approach. This does not scale. And the current approach is mostly bottom-up, that we have data, we have text, and we let machine read it. Of course, machine is not doing this thing right at the beginning. At the first round, they make 20%, it's like 50% of errors. But errors are atrocious. The machine can read the errors, then iterate over errors, round by round. So we can abstract, summarize structure from data, not design it. That's the best idea. Put design later. Just summarize from data, learn from data. That's best difference. And another difference is how do we present the knowledge. The original idea of semantic web is present with like triples and organizing triples as a perfect concept and properties. That approach is too costly, and it has many limitations. And now when we use agent, actually, there's a new approach called scale. Scale is a new ontology. It's kind of different, but it works. It works very better. And scales can enable agents to inference. It's very, very, very impressive. So that's the thing I tried. It's my personal experience with agentic ontology engineering. I tried with, we have passed like two sandbox and turn that into ontology. That's approach. It works very well. It's a bottom-up approach. So that's a book I spent most of time with. It's one of the first Chinese history book called Jie BAO. I turned the whole book into a knowledge base. It has 140,000 triples. It's not quite a large number, but compare that with what we have done 25 years ago. Like at that time, we are designing one ontology. It's quite small. It's like hundreds of triples. And I learned a lot from this practice. That there are three approaches I think most important. That first one is OTF. It's on the fly, that we do not design at first, but distill in all directions, iterations. Second is the JIT, just in time. So iterate very fast. Each step is minimal. Each step like 10 minutes or 20 minutes, but split iterations, keep it minimal. Lean startup. Third is the bootstrap. That basically we do not design anything. We always start from like 0 examples, but examples will show up in the process. So OTF, JIT, and bootstrap that enables us to build things from nothing. That's very magic, you know. When you're working on it personally, it's like, wow, how is it possible? It is possible. Okay. It's more detailed of skip, but give your members. So in recent practices, each triple costs 3 cents. You may say, oh, it's still expensive, but remember, this is not triples from structured data. It's triples from unstructured data. And Shiji is a very complicated book. So mostly it's the so-called T-box data. It's not A-box data. That's quite impressive. I think when I was a graduate student, it cost like $30 or $40 per triple. Okay. Again, we find triple is not the best way to describe knowledge. We coin a new concept called SKU, Standard Knowledge Unit. We divide knowledge into 4 layers: hard fact, soft fact, procedural skills, and Eureka. Eureka, you can see it like insights or something. Only the first level, hard fact, is representing the traditional structure way in JSON, but other levels are in Markdown. So it's like a wiki. We are building a wiki, but the wiki is the wiki content can be read by agents. And nowadays we call it a skill, but actually I think it's just wiki pages. That's why knowledge, how to present knowledge, triple is too low, and a document is too general. So we need to land it in the middle somewhere. And that's one of the approaches we tried, and it works. Also, harness. You may have heard a lot in the past months, and our practice is very important. So knowledge base is just a special case of software. It's a software. So all software engineering procedures can be applied to knowledge engineering. So knowledge base is a living software, and that's the key. It's a software and it's living. So Deborah McGinnis taught me knowledge engineering when I was in Rensselaer Polytechnic Institution. I think at that time, that ontology engineering is a waterfall. It's a waterfall approach. Stage 1, stage 2, stage 3, stage 4. And when Deborah write with Noy ontology 101, indeed they mentioned iteration in the paper, but actually there are no examples. So it really works in practice. But nowadays, with harness, iteration is a built-in nature, and at every level we have guided agents to ensure your output passed the QC, quality control. So we are landing here, Agent Web. So what's next? I think we still have a long way to go. Agent Web is still, I think, it's structured web, structured verb. I call it structured verb. But now there's still a lot more of knowledge that we can design. We can let it living just like lives on the web. I call it the meme web. So I thought a lot of other words, but after a decade, I can't find another better word. So meme is invented by Dawkins in the Gene, the book. And the Gene is the basic unit of culture in life. But meme is the most replicable unit of culture. And that's what Tim originally thought the web should be about. It's about exchange of knowledge. We need to find the best way to exchange knowledge, to let knowledge evolve into a new form of knowledge. I think we are not there yet, but that's the thing we need to work on maybe for another decade. I call it the meme web. To achieve that, I think we need to at least do three things. First, we need to standardize agent protocols. So agent web should not be a separate approach. I think most of consumers and product producers on web will be agent, not human. So agent protocol should be part of web standards. Second, trust exchange of skills or memes should be standardized. So we should have some new kind of knowledge representation language like RDF or Sparkle. But of course, not in descriptive logic, something new. Right? We don't know what it is, but it's kind of a next version of skill, but no skill. A third, governance of social machines. And I think the term social machine was first coined by Tim Berners-Lee in Weaving the Web, the book. It's in 1999. Finally, I think it will be something true. So how to make sure human-machine interaction and human-machine hybrid collaboration is reliable, is safe, it's for good, both for the human and the machines. That's about something we should work on. That's it. Thank you.